Let's talk about composition of functions. You can see in my first example here, I'm given two functions, f of x and g of x. This is the given part of the problem, and then the stuff underneath it is what we're being asked to compute. Okay, so we'll start with this notation here. We would say this out loud, f of g of x. This little symbol right here is a tiny open circle, so it's not quite a multiplication dot. It means composition. So it means f of g of x like this. So this is the fancy notation for actually doing this. So to actually get the formula we're being asked to compute, we really need to be careful about what function kind of comes first in this notation. So I have f of something. So I'm going to look at the formula for f, which is 3 plus the square root, and say, all right, 3 plus the square root. Whatever I'm plugging into f goes in this spot. And then what's going in this spot is the entire formula for g of x. So in this case, I'm going to put the whole 1 over x plus 2 inside this square root. This is different from the next thing we're being asked, which is g of f of x. So this is g of f of x. And again, the g is on the outside, so I'm going to kind of ignore the input for a second. Say, all right, g of anything is 1 over that plus 2. This is g of something. And then what I'm plugging in is the entire formula for f of x. So this 3 plus root x is going to go in the plug-in spot. This one does have some straightforward simplifying we could do. 3 plus 2 is 5. So we could simplify this to a 5 in the denominator, but otherwise there's not much else we can do. All right, the next problem up is g of f of 4. And there's two different ways to compute this in this particular example, and both of them will lead to the same answer. They're both perfectly correct. I'm going to talk about both ways just that you can pick what you like better. Okay, so g of f of 4, we could say, well, this is plugging 4 in for x in exactly the function we just computed, right? This is g of f of x, the formula. So we're saying, oh, we'll just plug in 4. So I could come over here to this formula and plug a 4 in for x. The square root of 4 is 2. So I come out with 1 over 7 as my output value. The other option for computing this is what you would most likely do if you didn't already have this work done out ahead, or if this work was inaccessible in some way. So if we didn't do it this way, I'm going to switch colors to make it clear. Or we could go about this kind of in pieces. So this means g of f of 4. And I can compute this from the inside out. So I would plug 4 into f to figure out what f of 4 is. So I'm going to go to the function f, I'm plugging 4. So this is 3 plus root 4. That's 3 plus 2 is 5. And we'd say, all right, it's g of what I just computed for f of 4. We said f of 4 is equal to the number 5. Now, separately, I can plug 5 into g of x. So that gives me 1 over 5 plus 2, which of course lands us on that same 1/7 that we had gotten doing it the other way. So in general, especially if you've already computed the function you're plugging into, you can pick between these two options. They should come out the same, and doing both is overkill. All right, the last question we'll answer for this f and g, you can see at the bottom here, is to compute the domain of g of f of x. The domain of g of f of x. So g of f is this formula that we computed up here. This is another one where there's two different ways to think about it. But I would say in this case, one way is probably, I don't know, I find it kind of easier on the brain than the other way. Okay, so the way that I recommend thinking about it is just always taking like the unsimplified version of the function they're talking about having the 3 plus 2 equals 5 is fine here, but if you ever had like a square root and a square cancel or something like that, you would want to go before that simplifying. And then just compute the domain of this function. Right, so we think, all right, my domain problems, the roots and denominators are a problem. Whatever's under square root, I need to make sure is greater than or equal to 0. So I know x has to be greater than or equal to 0. And then I also know what's on the bottom of a fraction. I want to find out what makes it equal 0 and then exclude that number. So root x plus 5. I want to find the x value that does this. Oh, and there's actually nothing. There's no solution here. Right, so if I subtract 5 onto this side, I'll have root x equals -5, but the square root only outputs positive numbers, so there's just no x's that do that. So in this case, it's just greater than or equal to 0. If we had gotten a number here, like this was a minus, so your answer is 25, you would say, okay, all these numbers, but then exclude the solution that came out here. Okay, so that's the way that I recommend thinking about it. You could think about it in 2 pieces, which is what our textbook recommends, which is you would think about g of f of x. So you think f of x, this formula, which has x has to be greater than or equal to 0. That's being plugged into this fraction. So you're still thinking about these same 2 domain restrictions, but kind of as separate functions entirely instead of separate parts of the same function. But no matter how you think about it, this should come out to the same solution. All right, the rest of the video, we're going to talk about doing this from a different starting position. So still computing composition values, not a composition formula, but values. When you're given either an XY chart, like I have here, or they might just kind of zoom in on a couple of these, right? So if we say, like this 1 and 3 in this chart, when x is 1, g of x is 3. Another way to say this is that g of 1, right, when the input is 1, the output is 3. So instead of giving you this whole chart with this in it, they may just say this statement. But either way, they're giving you the same information. Okay, so the first question asked is f of g of 0. That's f of, and I'm actually going to switch colors here, g of 0. Because we don't have a formula for f or g, we can't compute this the way that we did this problem right here, where you just plug the number in. We have to go about it this way, which is from the inside out, right? We computed f of 4 separately, then plug that in to the other function. So I'm going to zoom in on g of 0 here and say, all right, well, what's g of 0? I'll go to the XY chart for g and say, all right, when I plug in 0, I get 2. So g of 0 equals 2. So I'm going to say, all right, well, they're asking me to compute f of that. So now I'll switch to the f of xy chart and say, all right, what's f of 2? When I plug in 2, I get 5 out, apparently. So 5 is my final answer for f of g of 0. We'll do the next one similarly. And again, I'm going to color code it just because I find it helpful organization. So we have g of f of 3. And we'll go from the inside out. So focus on f of 3 first. I'll go over here. When I input 3, f gives me 2. So this right here equals 2. That's a coincidence. They both have a 2 in the intermediate step. And then g of 2, when I plug in 2, I get 0 out. So I'll say 0 for g of 2 as my final answer. The very last one here is g of f of 1. G of f of 1. All right, so we'll go to the f of x chart and find the y value that goes with 1. When I plug in 1, I get 4. So this is g of 4. But then here's the weird thing. When we go to g's xy chart here, there is no y value assigned to an x value of 4, right? So like the x values are 0, 1, and 2, and that's it. So that means something like g of 4 just does not exist. And that's actually our final answer. Like, we're being asked to compute something that just doesn't exist. This is a fairly common answer when you're starting a problem from an XY chart or just a couple of XY points like this. Because you're so limited in the points involved, very often they're asking you for something that just can't be computed.